All right, so I went ahead and did the math to kind of condense this into one complex number. You could theoretically just throw this into your calculator. If your calculator can handle complex numbers, it'll give you the value. You could also convert the top into a phasor, the bottom into a phasor, do the phasor division very easily, and then replace this with the correct rectangular value after you determine the phasor there. However, I didn't want to do all that on screen. Takes quite a bit of time, so I just threw it in my calculator. I did confirm that it works, so you should be fine doing that, or you can use your calculator. But from here, I'm just going to write this out again. I also condensed everything and resized it so it would fit. But this is going to be Vy times 1 minus, and then this term gives me a J 0.636, and then this last term is going to give me minus 0.318, and then I'm going to get another minus J 0.316. Okay, so this is what I'm looking at now. Can obviously combine like terms here to get a single complex value. 1 minus 0.318 is 0.682, is that right? 0.682. And then I've got a minus J 0.636. Let me just throw this, I don't want to make a mistake here. 0.948, is that right? 0.636 minus 0.316. Sorry, minus 0.316. 0.952, right. So I'm going to get minus J 0.952 here. And of course, I now need to convert this term into a phasor in order to divide it by this. Alternatively, I can convert this into a complex number and do the division the other way. But that depends on if your calculator is capable. So I want to make sure that I'm helping everybody, even those who don't have a calculator capable of doing that. And then I'm going to go ahead and do this phasor. So it's going to be 0.682 squared plus 0.952 squared, and then we square root. It's going to give me R, and then I'm going to do the tan inverse of 0.952, negative 0.952 over 0.682, and that's going to give me phi. So let's see what these values are. 0.682 squared plus 0.952 squared, square root. This gives me 1.17. And this tan inverse 0.952 divided by 0.682, I get negative 54.38 degrees. All right, so I'm here with 3.3 angle 0 is equal to Vy times 1.17 angle negative 54.38 degrees. I can now finally say Vy is going to be equal to 3.3 angle 0 divided by 1.17 angle negative 54.38 degrees. And finally, I get my Vy phasor. Actually, I'll just write it here. 3.3 divided by 1.17 gives me 2.82. Of course, my angle is going to be 0 minus negative 54.38, which is going to give me a positive 54.38 volts. And that is my Vy. I can rewrite it in terms of time, and I can say that Vy of t is 2.82 times the sine of omega t, which in this case was 2 pi times 5 megahertz times t, plus 54.38 degrees volts. All right, these problems are very tedious. I know you're probably getting a little overwhelmed by the math. That's okay. It is a necessary evil, and we can work through it together. I definitely recommend getting a TI-84 or some kind of calculator. You can probably, I mean, since a lot of this course material is going to be done at home, these homeworks, you can definitely use an online calculator to do a lot of the math, but I am just showing how it works at this point, just so that everybody who maybe doesn't have a calculator that can do this, or we need to be able to solve these problems on exams. I mean, obviously you're going to be allowed to use a calculator on an exam, but for people who use like Wolfram Alpha or something to do the math, still need to be able to figure out how to do this on an exam. So wanted to show this, but moving forward, to save time on these videos, I might start doing some more of the math using my calculator just to save time. Because at the end of the day, what's important is the circuit's concepts. The math is obviously very important, because without being able to do the math, we can't really solve circuits accurately. But the important piece is the concept. So we're going to focus on that, and we're going to go ahead and stop this video. And just obviously feel free to reach out if you have any questions. And in the next video, we're going to get into superposition, which we learned in 220, but we'll see an example in AC.